Hello everyone, welcome to the YouTube channel Education Adda. So in this video we will start discussing the remaining portion of the exercise 10.2 class 10, that is circles. Remaining portion of the chapter circles. In the previous videos we have discussed about the question number 5, 6, 7. Now we will start with the question number 8 of exercise 10.2. So let's proceed towards the question number 8 of exercise 10.2. Question number 8. In question number 8, what we are given there is a quadrilateral ABCD is drawn to circumscribe a circle. Like there you are having a quadrilateral circumscribing a circle at the points P, Q, R, S. We have to prove that AB plus CD is equal to AD plus BC. That is, we have to prove that the sum of the opposite sides of a quadrilateral circumscribing a circle is always equal. Now given a quadrilateral ABCD circumscribing a circle, to prove AB plus CD is equal to AD plus BC. Now let's start with the proof. As in theorem 10.2 we have studied that tangents to a circle from same point are equal in length. Tangents to a circle from the same external point are equal in length, as we have studied in theorem 10.2. So AP should be equal to AS, therefore AP is equal to AS, take it as equation number 1. In the same way BP and BQ are equal, as BP and BQ are tangents from point B, so BP is equal to BQ, let it be equation number 2. In the same way CR is equal to CQ, CR is equal to CQ, and DR is equal to DS. Let them be equation number 3, 4. Now we have to adding first, second, third, fourth, we get what we get here: AP plus BP plus CR plus DR. While adding, we have to add the LHS to the LHS and RHS to the RHS. Means the complete LHS should be added on the left hand side and complete RHS should be added on the right hand side. Let us have it there like this: AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. So we just have to rearrange these terms to find the required sum. Like when we combine AP and BP, CR and DR in the same brackets, in the same way we can combine AS, DS, BQ plus CQ. So when we add this, what we get? When we add all this, you can see here, when we add all this, what we get from there? When AP and BP are added, we get AB. So AP plus BP gives us AB. BQ plus CQ gives us BC. BQ plus CQ gives us BC. DR plus CR gives us CD, and AS plus DS gives us AD. So when we add it, what we get here? AB plus CD is equal to AD plus BC. So this is the required proof. This is the required proof of this question, where we have to prove that if there is a quadrilateral circumscribing a circle, then the sum of the opposite sides of the quadrilateral would be equal. So we have just used a simple theorem that we have studied as theorem 10.2, that the tangents drawn to a circle from the external point are equal in length. So AP, AS are equal, BP, BQ are equal, CQ, CR are equal, DR, DS are equal. By using this equality, by adding this equality, we can find the required sum that we need. So this is question number 8. This was the question number 8 of exercise 10.2. This is what we have to prove here. Hence, proved the required result. So if you observe the next questions, then you will find a direct link in question number 8 and question number 11. Now after question number 8, we will direct jump to question number 11 in this video. Let's have the question number 11 here. Question number 11, prove that. Let us have a question number 11 there. Prove that a parallelogram circumscribing a circle is rhombus. So in question number 11, we have to just prove that if there is a parallelogram which is circumscribing a circle, then this parallelogram would be rhombus. So as in question number 8, we are given a quadrilateral. So in question number 11, we are just given a parallelogram. We will change in the given in the to prove. We will have a little bit of change in the given and the to prove. The rest of the question would remain same. We just have to use a little bit of addition there. That's why we just jump from question number 8 to question number 11, because it is directly linked, so it will help you to understand easily. So in question number 11, we are given that a parallelogram ABCD is circumscribing a circle, but we have to prove that ABCD is rhombus. This parallelogram ABCD, again the same diagram we are using. So again the same points, since tangents from the external point are equal. So AP, AS are equal, BP, BQ are equal, CQ, C are equal. Again by adding same result that we have proved in the previous question, that is question number 8. We just have to rub hence prove from there, because in this question we don't have to prove this. So after first, second, third, fourth, we will take it as equation number 5. Now, one more property, as we know, opposite sides of a parallelogram are equal. As we know, opposite sides of a parallelogram are equal. So AB and CD would be equal, AD and BC would be equal. Therefore, AB is equal to CD, equation 6. AD is equal to BC, equation 7th. Now if we use this equation 6th and 7th in equation number 5th, using 6th and 7th in equation number 5th, what we get? You know, AB and CD are equal here, so we can use AB in place of CD. In the same way, AD and BC are equal in the equation 7, so we can use AD in place of BC. So we get AB plus AB is equal to AD plus AD. It gives 2 times AB is equal to 2 times AD. When 2 and 2 are cancelled, this gives us AB is equal to AD. So AB is equal to AD. So here in the parallelogram ABCD, now we have the one pair of adjacent sides is equal. In class 9th, we have studied that if one pair of adjacent sides of a parallelogram is equal, then this parallelogram would be a rhombus. This is the property that we have read in the unit quadrilaterals in class 9th, that if one pair of adjacent sides of a parallelogram is equal, then this parallelogram would be a rhombus. So here we have proved that AB is equal to AD. So since one pair of adjacent sides of parallelogram ABCD is equal, therefore ABCD is a rhombus. So this is what we need to prove here in question number 11, that if if a parallelogram circumscribes a circle, like there we are given a parallelogram ABCD circumscribing a circle, so we have to prove this parallelogram would be a rhombus. So we have used the same concept as we have used in question number 8, that if tangents from the external point are equal, then AP AS are equal, BP BQ are equal, CQ CR, DR DS. Adding this, we will get this AB plus CD is equal to AD plus BC. Now we know that opposite sides of a parallelogram are equal. So AB and CD are equal, AD and BC are equal. By using 6th and 7th equation in equation number 5th, we get AB plus AB is equal to AD plus AD, that is 2 times AB is equal to 2 times AD, that is, which gives AB is equal to AD. So now one pair of adjacent sides of parallelogram ABCD is equal, so ABCD is a rhombus. So this is what we have studied in class 9, this property, that if one pair of adjacent sides of a parallelogram is equal, then it is a rhombus. So this was question number 11 that we have done here. Now we will go for the question number 9. Let's have a clear board here to prove the question number 9. So question number 9. In question number 9 we are given there that there are two parallel tangents. There are two parallel tangents which are drawn to a circle xy and x dash y dash. Let's have the diagram there. I am just using a simple ring to draw the circle. Now we are given that there are two tangents like this. Use the scale to draw the parallel tangents. These tangents we are given as xy and x dash y dash. Xy and x dash y dash, which are touching the circle at points P and Q. And there is another tangent. There is an other tangent AB which is touching xy at A, x dash y dash at B, and the circle at the point C. And O, suppose, is given as the center of the circle. So we are given here, what we have to prove is that angle AOB, this angle AOB is 90. So this is what we have to prove here, that angle AOB is 90. Okay, so let's have the given. Question number 9. What is given there? So here we are given is that xy and xy and x dash y dash are parallel tangents drawn to a circle with center O. With center O at the points of contact P and Q respectively. So AB is another tangent. AB is another tangent touching circle at point C, which is touching the circle at point C. So what we have to prove there is that angle AOB is 90. What we have to prove here is that angle AOB is 90 degree. So listen students, to prove this we have to make a little bit of construction here. We have to use a little bit of construction there. What we have to do there, we just have to join OP, OQ and OC. OP, OQ and OC. Join OP, OQ, OC. Okay. Now let's come to the proof there. So once again we will use the make of simple statements that we have studied in the previous geometry, either in the circles or in the lines and angles or in the triangles in class 9. The smaller result that we have studied we will use there. Okay. So now let's come to the proof there. To prove, let us take the triangles APO and triangle ACO. In triangle APO and triangle ACO, APO and ACO, AP and AC are equal. Why? Because these are tangents from same external point. These are the tangents from the same external point drawn to the circle, so they would be equal. OA is common in both the triangles. OA is common to both. So OA is equal to OA because this is common in both, and OC is equal to OP, that is OP is equal to OC. Reason, this is the radius of same circle, radii of same circle. So since three sides of the triangle are equal to each other, so obviously these two triangles would be congruent. Therefore triangle APO is congruent to triangle ACO by SSS rule. SSS congruence rule यूज करके हम इन दोनों ट्राइंगल्स को कॉन्ग्रेंट कर सकते हैं. नाउ लेट्स सी, इफ दीज टू ट्राइंगल्स आर कॉन्ग्रेंट देन ऑब्वियसली एंगल 1 and angle 2 would be equal. Angle 1 would be equal to angle 2, CP, CT, corresponding parts of congruent triangles. It gives angle 2 is half of this complete angle, PAB. Because 1 and 2 are the components of PAB, since 1 and 2 are equal, so angle 2 is half of PAB. Let it be equation first. Similarly, this one angle, that is angle OBC, which we have marked here as angle 3. Angle 3 is half of angle QBA. QBA second. Now, as we see that XY and X dash Y dash are parallel tangents and AB is transversal, like in class 9th we have studied that if a transversal intersect two parallel tangents, then the interior angles on the same side of transversal are supplementary because these are co-interior angles. So in the same way, in the given figure we have PAB and QBA. QBA and PAB, because X dash Y dash are parallel, so these two angles are also supplementary. That is, since XY is parallel X dash Y dash and AB is a transversal. AB is a transversal. Therefore, angle PAB plus QBA is equal to 180 degree. Reason for this is co-interior angles. Co-interior angles. Now, if we divide the whole equation by 2, that is PA by QBA upon 2 is equal to 180 by 2. Dividing both sides by 2. What we get there? We get half of PAB, that is angle 2, half of QBA, that is angle 3. Angle 2 plus angle 3 is equal to 90 degree. Let it be equation third. So where we have taken this from? First and second. From first and second we have find this. Now if we come in the triangle AOB, so angle 2 plus angle 3 plus angle AOB, this complete angle, that is AOB, this would be 180 by angle sum property. Now in triangle AOB, angle 2 plus angle 3 plus angle AOB is equal to 180 degree. Reason? Angle sum property, that is sum of three angles of triangle is 180. So angle 2 plus 3, already we have proved it as 90 degree, plus AOB is equal to 180 degree. We use this value from equation number third. So angle AOB is equal to 180 plus 90, when transposed to the RHS it becomes minus 90, it gives angle AOB is equal to 90. So this is the result we need to prove in question number 9, that if xy and x dash y dash are two parallel tangents to a circle, then prove that angle AOB is 90 where AB is another tangent touching the circle. So dear student, this was question number 9 of exercise 10.2. Now we will proceed towards the question number 10. So let's have the question number 10 now. Let's clear the board here. Question number 10. So in question number 10 we are given that, prove that the angle between the two tangents, we have to prove that if there are two tangents, then the angle between these two tangents is supplementary to the angle subtended by the line segment joining the point of contact at the center. Suppose we are having a circle here and these are the two tangents. These are the two tangents. We have to prove that in the angle between these tangents, suppose PA and PB are two tangents, angle between these tangents is supplementary to the angle between the line segment joining the point of contact to the center. That is, angle between the tangents is always supplementary to the angle between the radius drawn at their point of contact. This is what we have to prove in question number 10. So for this we have to given to prove and prove. So what we are given there, as we are not given any dimensions, any particular tangents here, so let us suppose we are having two tangents PA and PB drawn to the circle from the point P. Let PA and PB are tangents to circle with center O from point P at points of contact A and B respectively. That is, PA and PB are two tangents to the circle from point P to the points of contact A and B. So what we have to prove there is the angle between the tangents, that is APB, is supplemented to the angle between the radii plus AOB is equal to 180 degree. So prove, as we have studied in theorem 1, that radius is always perpendicular to the tangent at the point of contact. Since radius is always perpendicular to tangent at point of contact, therefore OA would be perpendicular to OB and OA would be perpendicular to PA and OB would be perpendicular to PB. PA and OB perpendicular PB. It gives, let it be angle 1 and angle 2. Angle 1 is also 90 and angle 2 is also 90. Now, if we observe this figure AOBP, then this is the quadrilateral AOBP. In quadrilateral AOBP, by angle sum property, that is angle AOB plus angle 2 plus angle APB plus angle 1 is equal to 360. Reason? Sum of 4 angles of quadrilateral is always 360 degree. So AOB plus angle 2, which is 90, we have proved, plus APB plus angle 1, which is also 90, we have proved, is equal to 360 degree. So AOB plus APB is equal to 360. 90 plus 90, 180. When it transposed to the RHS, it becomes minus 180. So AOB plus APB is equal to 180 degree. So this is what we have to prove. Hence proved. That is, the angle between the two tangents is always supplementary to the angle between the radii drawn at the points of contact. So okay students, this is question number 10. So in this video we have discussed question number 9, question number 10, question number 8 and question number 11 of exercise 10.2. In the next videos we will discuss the remaining questions of exercise 10.2. Thanks. Have a nice day.